Good morning, everyone. Let me see by a yes or a P if you are present here. If you write a P if you are here. Hello. I believe you can all hear me. I need to be sure. So if you are here and you can hear me, just write yes. And then let's pick it up from there. Okay, so it means I have some people here and then we can go on. All right, so today I'm going to be doing more on data mining classification basic concept. So I hope that goes well with everybody. As we move on, I know there are some challenges, but then in our next class we'll be meeting face to face and we'll do more of the practical. Online, I think it's better I do the theory. And if you have not subscribed, please subscribe and ensure you engage me on the chat section to leave your comment so that if there's any uh, thing I need to address, I'll address it as such. If you're having problems, you can also send your message through Telegram and I'll respond to it as well. For V class, we would use V class, but I'm still struggling to get access to V class. My courses are not on my portal. So until I get my classes on my portal, that's the challenge we are going to be having. But I think most of the assignment will be submitting through V class pretty soon. So let's be on the same page. So, what is the definition of classification? Classification is basically a collection of records that is a training set. So each record is characterized by a tuple, which is XY, where X is the attribute set, and then Y is the class label. So X attribute is also a predictor, it's an independent variable, and it's the input. And then Y class response, or is a class is the response, is the dependable variable, and that is also the output. So what's the task? The task is to learn a model that maps each attribute set X into one of the predefined class label Y. So let's move on to understand it well. So here is an example. Now you have a task. The task is to characterize email messages. So the attribute set X is where feature is extracted from the email message header and the content. So when the email comes, we look at the content of the email and then the header of the email. And then we classify it whether it is spam or it is not spam. So Y is our label, and we are trying to determine what X is, or identifying tumor cells. So here, the attribute X is the features extracted from an X-ray or an MRI scan. Then what we're interested in knowing is whether there's a malignant or there is what? A benign cell. So that is what we are looking at. Same with the last. So the general approach for building a classification model is this. We have what we call the training set. The training set help us to train or induct our algorithm. So we have a predefined training set that help us to determine certain answers. So what happens is that the learning model learns from the training set, and then it builds the model, right? Then with the model we have built, we deduct by applying the new model we've built on it. So when you check the training set, all the attributes have been answered. So you have ID, homeowner, marital status, annual income, and then defaulter, borrower. The last column is our Y. The first 4 columns, or the first 3 columns, which is the house owner, marital status, annual income, is our X. So we train based on what we got in our Y to know that in subsequent X, this is possibly the answer we are supposed to get. And so to test the model, we apply a new set of data where the attribute combined here is the house owner, marital status, and an annual income. And when all these 3 are put together, we determine Y, which is to know whether an individual is going to be a default borrower or not. In other words, if we give a person loan, will they default? Default means they won't pay, or will they pay? So there are a lot of classification techniques that exist. We have the decision tree based method. We have the rule based method. We have the nearest neighborhood method. We have the naive Bayes and then Bayesian belief network. We have the support vector machine. We have the neural network, deep neural net. All right. So those are base classifiers. Then we have the ensemble classifier, which is the boosting, bargain, random forex, etc. So an example of a decision tree is this. So remember the training set that we had. So that's the training set. So based on the training set we have, we've built this particular model. So the model you see on the right side, or the diagram you see on the right side, is a decision tree approach. Is a decision tree approach. Please, if you are here with me, type in decision tree, so that I know you are here with me. So the house owner, or we split attribute. So we have house owner, marital status, and then income. So we have 3 attributes that we have. So the first thing we look at is, if he's a house owner, yes. What is the result? No. He is not going to be a defaulter. All right. Which means that house owners are responsible. That is what it implies. So we can risk giving them what? That loan. Now, if he is not a house owner, what is his marital status? Is he single, or is he divorced, or is he married? So there are 3 options there. But we've come to realize, based on our training set, that people who are married are naturally not defaulter borrowers. In other words, they are also responsible. They may not have a house, but they are responsible, and as such, we can trust them with our money. All right. And so for them we can give them a waiver. Right. So yes, they would also not default on the money they're supposed to give. Now, the other thing is that if the person is single or divorced, we have to consider if indeed they would be defaulters or not. And then we realize that, singles and divorcees who have their income, right, that is 80K, they are also what? No, they are not default borrowers. But those who have greater than 80K yes, are defaulted. That's quite interesting. But there are a lot of reasons why that could be happening. All right. And so that is where the tree there is based on the training data that is available to us. And so we cannot determine much on that unless otherwise we look deep into it. So this is just a small training data set that we are using to model. So when we apply, so this is it. We've built that. So now we want to apply it to your test data. So we have a test data there. Homeowner, married, 80K, what will be their state? What would be their state? So what we do is to check from the root here. We check from the root to be sure that indeed. So first thing we check is house owner, right? No. Then we move to the next. All right. Then we check no, yes. And then we verify again. What is their state with regards to their marital status? All right. So we cross-reference that. And then we say, he's married. All right. If he's married, then of course it's ending there. No. Assign defaulter what? So we can ended here because the two meet a certain. So we assign what? No to. So the question is it before? No. So we have this, and then we use the same thing to check. Now, there can be more than one tree that fit the same data, right? In certain instances, there could be more than one tree that fits the same data. And so it's important that when you're training the training data sets that you have should be well versed, because the error in your result would be as a result of the training set you used. Now, so here is what the tree indexing algorithm, right? This is where we pick the training set. We're able to learn and develop the model. Then we apply the model, and then we're able to deduct what a result from it. And that is the decision tree induction. There are a lot of algorithms in that regard. So we have the Hunt algorithm, one of the earliest algorithm, the CAT ID3 C4.5. All right. So there are a lot of algorithms that. So when we pick the general structure of the Hunt algorithm, right? So let DT be the set of training records that reach a node T. All right. So the general procedure is that if DT means data training, so T there would mean training data set, right? Contains records that belongs to the same class. YT, that is the Y would be what? Our result or the output by the training set. So here, if I have to pick, let me draw the entire data set here. Is X, right? Is our X data. And then what we have here, let's see if I can okay. What we have here is our Y, right? So this is YT because this is our training set. So YT. So the statement that we are getting is DT. So belonging to the same, let T, then T is a leaf node label as what? YT. So if DT contains records that belong to more than one class, use an attribute test to split the data into smaller subsets. Repeat or recursively apply the what procedure to each subset. So let's look at it. So we have defaulter equals to what? No. Right? Where we have 7,3. Yeah. So let's look at this end. We have defaulter no. No means that we have 1, 2, 3, 4, 5, 6, 7 no's. And then 1, 2, 3 yeses. Right. Okay. So we have house owner. Yes and no. Now we are working it from the top. So when we pick house owner, right? How many yes correlate with a no? So when we pick this, there are yeses. So we pick yes, then we come and draw yes, no, because it's a binary response. Defaulter equals to no, defaulter equals to no. So here, based on this, when we pick house owner, yes, 1, 2, 3, there are 3 yeses. And all of them have a no, and none is a yes. So that is why our y is 0. Then we check the no aspect, right, of the decision, the trading set. So we have 1, 2, 3, 4, 5, 6, 7 no's. Now, out of the 7 no's, we notice that this no corresponds to another no, but then there's a no here that corresponds to a yes. So you realize that there are 3 no's that correspond to a yes, and so we have 4 no's to 4 no's, and then 4 no's to 3 yeses. I hope it's clear. Please put your question in the chat. I'm reading them. Class there. I don't know there. You know me explaining. Hunter already know me. There. Me sure. Yeah. Mining, I mean, data mining. To me explain it. Sorry, guys, that was a distraction. All right, so let's continue. Then we have. I hope we are getting the A and B, because I'm continuing. So now we are adding an additional component. So from here, we have only 2 options. So because we have yeses here, we need to expand it. Remember, our goal is to determine the no's. So wherever there's a yes, it means we need to move forward if something can change. So we have marital status, which we are adding to where we have the 3 yeses, which is at this end. So we have marital status, then we split into 2. Single, divorced, and then what? Married. Now, you can split into 3, but we realize that when we check, single and divorced still have something in common. So whether you're single or you're divorced, when you're divorced, technically you're still single. Is that you came out of marriage. So we are putting them together. Married means there are 2 people together. All right, so there are 2 people together. So when we pick the marital status, we are combining the 2. So there is single. So now from this point, we are checking only those that have the combination with the homeowner, and we are ignoring the ones here. So if I have to mark, the one I'll mark with red, we are not touching them, so that we get so we notice that. So we have this, we have that, sorry, we have this. Now, for all those 3, from this end, as long as they were homeowners, the answer we got was no. Remember, our goal is to get a no answer. Right? It's a no. So now we are checking the rest. So when we come to this end, we are checking now. There's a no here. The corresponding is also for a married person is no, right? So we have one no, so we can cancel this out, which means we have one here. Then we come to another no, right? A no, but then it's single, right? Single, and it's also a no. So we come here, we have one no here, right? Then we check a no, who's a divorcee, but then it's a yes. So we have one here. We check again a no, married, no. That's another here. Then we come to the number 8. We check number 8. Let me use the pointer so you guys can see. So number 8, no, single, which means it will come here, right? Single. It's also a yes, which means that we have another yes here. Then number 9 is a no, which will be here. Is he married? Said no. Married, we have the no, so we are checking the married, right? So he's married. Another no, right? So we have that, and then we check the last one, which is single. And then we have a yes. So we have a third yes here. So based on this, we can say that when a person even is not a homeowner and their marital service states that they are married, then no, they are not a defaulted borrower. So defaulted, well, just those with defaulted not, which is means that we can give them a loan. So with this, we've come to a conclusion that when a person is not a homeowner and the person is married, they are not a defaulter. But then when we check the marital status of single and divorcees, there's still a little, because only one person is not a defaulter. There are 3 people or 3 data sets that shows that being married or divorced can make you a defaulter, which is a yes. So we need to move further to the last attribute that is given to know what can we combine to make a person not a defaulter. And that is when we move to the next slide. So now our interest is in, so when we check, right? When we check, our interest is going to be only, let me use the pen so that before we move to the next slide, our interest is going to be those who are single, right? So we are checking single and divorcees who are not homeowners. So we have 3. So we have 3. Then we have 5, 6. No, sorry, not 6 is not included. 6 is not included. Where's my eraser? 6 is not included. So we are looking for those that are no and single at the same time. So we have no, single, 1, no, divorced, 2. This is no, married, and already it's a no, so we no, single, right? 8. Then we have no, single. So we have 3, 5, 8, and 10. Someone should type that in the chat box. 3, 5, 8, 10. Okay, so let's move on. Jeffrey, thank you. So now our interest is in 3, 5, 8, and 10 for the next. So now that we know we've done this, we have reduced to the only 4 left. So the 4 that is left is here, right? So we are now going to check who would be a defaulter and who would not be a defaulter. So our interest is to get a 0 for a yes or a 0 for a no. And then if possible, only that. And then we can end it. So now we check 3. When we check 3, the person is what? Single, sorry, not a homeowner, single, and 70K, and it's a no. Then we come back, we check 5. We have, because we need to understand what will be the minimum amount. So if there is that is a no, then it means that we have this 70 income, right? We don't know, but all we know that 70K is what? No. So we are writing it down. Then we check the next thing, which is 5. 5 is also what? No, divorced. 95K is yes. So we have a 95, which is also what? A yes. Then we check 8, because that was what we did. 5, 8, right? So 8, we have no, single, 85K, and it's what? Yes. So we have 85 here as well, which is also a yes. Then we check the last one, which is what? 10. Single, sorry, no, that's a homeowner, single, and what? 90K, and it's also what? A yes. So we have another what? 90K. So based on these two that we have here, based on the two write-up that I've done here, we can say that, okay, it looks like anybody earning 85 plus is likely to be a defaulter if the person is single or divorced and not a homeowner. All right. So that's why we have this here. So we are saying that if an annual income, right, is greater or equal to 85, defaulter is yes. And so we have 3 trading data sets that combine those homeowners to get that. So we have 0, 3 for yes, because, and then we have only 1, which shows that anybody less than, if the person is not a homeowner, marital status is either single or divorced, and earn less than 80K, is not a defaulter. Right. So that is based on the training set that we have. That is what we're able to get. Do we understand? Are we? I mean, we have to work. You have to work examples to know that. But are we all here? Now, there is still a problem with this kind of algorithm. If you look at it carefully, you notice that there are still some issues that we can actually get with this particular algorithm. So, design issues of this decision tree induction is that how should training records be split? Right. So, method for expressing test condition. This is depending on an attribute type. All right. Measure for evaluating the goodness of the test, a test condition. There's another question is how should the splitting procedure stop? So stop splitting if all the records belong to the same class or have identical attribute values. And then we also do early termination. Right. So that is those are some of the things, right? Now, method of expressing the test condition, right? Depending on the attribute, we can have binary, nominal, ordinal, or what? Continuous. So this is what we have. We have a multi-way split, right? Where we use as many what partition as distinct values. So we have marital status, which was 3. We can split into 3. That's a multi-way. Then a binary split, we divide it into 2 subsets. So you notice that marital status, we have married, and then single divorced, or we can have single married divorce, or we can have single married and divorced. And it depends on how the data set also behaves. All right. Yes. So in the ordinal split, we are looking at it in order. Right. So we have shared size where we're looking at small, medium, large, extra large. That's a multiple or multi-way split. But if you want to go by the binary approach, then you can group based on the values or the attributes, properties among the output will determine that. Then we have the continuous split, which is the greater than, that's the annual income. Is it greater than 80K, yes or no? That's binary. The multi-split is using the actual values to determine the, what do you call it, the lower boundary and then the upper boundary of the value. So with this one, right, this is less than 100K, or this we have a lower boundary of what, 100K, and then we have a upper boundary. So this 100K here with the square bracket means that 100K in itself is not part, right? So from 100K to, right, 25K. Then we have similar here, right? That's a range. So splitting based on continuous attribute, right? So different ways of handling it. So we have the discretization is the form to form an ordinal category attribute, that is range, can be found by equal interval brackets, equal frequent brackets, that's parentheses, or clustering. So we have static and dynamic, depending on how you want to go about it. Then we have the decision tree approach. Consider all possible split and find the best cut, and can be more computive or compute intensive. In other words, when you want to compute to know the best place to split, if you have very big data sets, then that becomes a challenge, right? Okay, so how do you determine the best split? So before splitting, there are 10 records of class 0 and 10 records of class what? 1. So you have gender, car type, and then customer ID. So we check the gender, we see what you have. You have C0s, which is 6, C1s 4. Then you have no. Gender, yes and no would mean male and female, basically. I mean, so when you check, you have 1, 2, 3, 4 females that have C0s, that is here. And then we have 1, 2, 3, 4, 5, 6 that have a what? C1. So this is male and female, basically. That's it. Then you have these, the car types as well, whether family or sport or luxury. So we have family, sport, luxury, 3 different types of cars, and we split it based on what? The class attributes that we are looking for. The same applies to the customer ID. All right. So we can use the greedy approach, not with pure classes distribution are preferred, right? So we need a measure of the node impurity. Higher degree of impurity and lower degree of impurity. I mean, that is if it's statistics student, I was going to be very much keen on this particular mathematical, but then we can exempt ourselves from the statistical computation. So here, when we are told to find the best split, compute impurities, measure P before splitting, then 2, compute impurity measure M after splitting. So impurity measure for each child node, you will compute the impurity measure for each child node. M is the weighted impurities of the child node. Choose the attribute test condition that precedes or produce the highest gain. So gain is equals to P minus M, or equivalently lowest impurity measure after splitting M. So just get to understand the procedure. I'm not going to make you do this, the misclassification error and the rest. Right? Just understand the procedure. Just understand the procedure. All right. So we have this. Any question? This mathematical computation, I think I'll do it in class so that it becomes easy. So we'll treat that in class. Is there any question, please, before I move to the next thing? Now, I have actually shared I have shared how do I call it? A link with you. So try as much as possible to follow the link and try your hands on the algorithm that is in the video. So this is it. So here it's more on classification, and I think we'll be doing on decision tree. So this is a simple classification method, and follow it so that when we meet, when are we meeting? Tomorrow or Wednesday? When are we meeting? Tomorrow or Wednesday? Ni, I won't go over. Where were you when I was talking? Because you didn't ask me a question. She asked questions. Don't say I don't understand anything. Understand. Tomorrow, please. Tomorrow we'll meet face to face. I think we'll find a classroom. Let's meet face to face tomorrow. Please bring your computers. Bring your laptops. Bring your laptops when you are coming. Bring your laptop so that we can do some practical session during the face when we meet face to face. We'll find a class and then try and do a face to face. All right. So, is there any question? No question. Then we can bring the class to a close. And then the next 1 hour left, use it for the link I have sent you to learn about the classification of personal income. So this is what you have there is classification of personal income, and then we'll see. I said tomorrow we are meeting face to face, unless I change my mind. So don't write there online. We are meeting face to face. And bring your laptops. We are meeting at the same time tomorrow, so don't ask me what time. The class has a time, so we are meeting at the same time. Okay, thank you all for your cooperation, and then looking forward to us meeting tomorrow. Have a nice day.